Um, okay. Hello, everyone. Let's start with a little motivation, a little meditation to generate a positive motivation. So first, spend a minute or two quieting your mind and focusing your attention. So we can do some placement meditation for a couple minutes. Then visualize oneself surrounded by all sentient beings. So it can begin with one's friends and family, one's female friends and family to one's left, behind you, beginning with one's mother of this life, and then all the aunts and grandmothers and so forth to your left and behind you. And then on your right, your father of this life and all your male friends and family. And then as we've done before, gradually bring to mind those whom you're most prone to become angry with, seated directly in front of you, facing towards you. And then all the other sentient beings in human form seated all around you. And remember how you're interconnected with them. And the same as they're the same as you, and wishing to have happiness and wishing to be free from suffering. So then, generate a positive motivation, thinking about why, why it's important or why we want to be here, thinking about emptiness and dependent origination, and in this case, quantum mechanics. So I'll read you a little passage from this physicist, David Bohm, who's one of the ones we'll discuss a little bit today. Yeah, as a kind of also a basis for generating positive motivation. So he says, or he writes, it is proposed that the widespread and pervasive distinctions between people in terms of race, nation, family, profession, etc., which are now preventing mankind from working together for the common good, and indeed, even for survival, have one of the key factors of their origin in a kind of thought that treats things as inherently divided, disconnected, and broken up into yet smaller constituent parts. Each part is considered to be essentially independent and self-existent. So, yeah, just think about why it's important to meditate on dependent arising and emptiness and generate a positive motivation, and if you can, a bodhicitta motivation. And if you like, you can visualize the field of refuge, or yeah, in the space before you, either Shakyamuni Buddha or any other object of refuge you like to visualize. And then bring to mind the ability of the Buddha Dharma Sangha or any other object of refuge. Bring to mind their ability to protect one from the suffering of samsara, oneself and all other sentient beings from the suffering of samsara. Generate a mind of faith, turning to them for refuge. Okay. So we can continue. Yeah, so today is it's the fifth session in this module on wisdom of emptiness, right, and discovering Buddhism. So yeah, we've done a module on, let's see, just an introduction to emptiness. Then, I mean, not a module, a session. The first session was on just introduction to generally why it's important to learn about, meditate on emptiness. The second session was on identifying the object of negation. What, when we talk about empty, we're talking about empty of what? It's inherent existence or independent existence. Then the third session was looking at, when you talk about the object of negation, there's the thing you actually negate, which is inherent existence or independent existence or things existing from your own side. And then there's the ignorance grasping at the existence of that which doesn't exist, right? The ignorance which grasps. So there's the ignorance grasping at inherent existence. And then you can divide that ignorance into, well, maybe before I go to that. So then the wisdom part is seeing that the thing that ignorance grasps at, the object of negation, that it doesn't exist. So the wisdom realizing that the thing that's grasped at by that specific ignorance doesn't exist. So then those three, the object grasped at, the ignorance which grasps, and the wisdom which sees the lack of that. And then you can add a fourth thing, the thing which is, well, the object of the wisdom, right? So basically you can divide up into two sets. On the ignorance side, there's the object and the mind grasping. And then on the wisdom side, there's the thing realized and the mind realizing, right? So, but those two different sets of two each, an object and a mind, you can divide up into two each, right? In relation to the person and in relation to phenomena. So in the third session, we looked at, well, how to meditate on the selflessness of persons. So in relation to the person, then there's, we can grasp at the person as inherently existing is the object of the ignorance grasping at the self of persons. And then, so in the third session, we did the analysis. How do you negate that and thereby generate the realization of the selflessness of persons, which is the object realized by the wisdom realizing the selflessness of persons. And then in the third session, we looked at, so in the third session, we looked at the selflessness of persons. In the fourth session, we looked at the selflessness of phenomena, which in this case, we essentially did just the same, this 4-point analysis, same meditation structure, the 4-point analysis, which we did in relation to the person. We can also do in relation to phenomena. So again, phenomena just refers to everything else that exists that's not a person, basically. So, but especially what's important in terms of emptiness is this constituent parts of a person. So once we analyze to see that, oh yeah, the person doesn't exist from their own side, we tend to grasp at, well, maybe my body exists from its own side, or my mind exists from its own side, or the whole collection of those. So we tend to grasp at one of the constituent parts, or the whole collection of the constituent parts of a person as existing from their own side. Yeah, and actually that grasping is slightly more fundamental in terms of how samsara arises. First, we grasp at the things existing from their own side, and then we grasp at a person existing from their own side. So that's what we looked at in the last week in the fourth session. So now we're in this week, the fifth session. Yeah, we're looking at quantum mechanics. So how quantum mechanics and emptiness are similar. Yeah, similar. I'll focus on the similarities. There are some different. I mean, obviously there are a lot of differences. I'll mention some of those, but yeah, I'll mention those. So the reason we're talking about this is largely because His Holiness Dalai Lama mentions it almost every time he talks about emptiness and dependent arising for the last 10 years, but especially, the last few years. His Holiness mentions how the similarities between the two in terms of showing how phenomena are primarily dependent arisings, and they don't. I mean, at least at the very micro level of quantum particles, quantum phenomena, that they don't seem to have. I mean, just from the point of view of quantum mechanics, that they don't seem to have any existence, any independent existence or inherent existence. So the similarities really are like very striking. And how, yeah, thinking about just, from the point of view of physics and quantum mechanics, looking how phenomena, this kind of the way phenomena appear to exist as inherently as discrete, independent entities, how that breaks down, by looking at phenomena in different ways with different experiments. That's very helpful for breaking down our fixed concepts of, well, usually we don't think about quantum particles, but our fixed concepts of other things that are, physical things that are composed of quantum particles, how it helps to break down our concepts of things as independently existing or discretely or concretely existing from their own side. Yeah, and it's just, it's really fascinating to see how, a lot of the kind of phenomena that in quantum physics, quantum mechanics are discovered, how, they really do, you can see, break down our concepts of the world. So, so I'm trying to present, but I'm not, I'm not a physicist. I'm not that good at science. So, but I have been reading a little bit about this stuff for a couple of years, and then especially for this session. So I'm basing my presentation on basically mainly two books, and then some stuff from the internet. So there's one book, and actually I was encouraged to see there's, one of the scientists who's has some good things to say in this discussion between Buddhism and physics is Michael Bitbol. He's a French physicist, Michael Bitbol. So a lot of the physicists that I'm drawing from, they've mostly all been involved in this dialogue, the Mind-Life Institute, right? These set of dialogues between His Holiness and scientists that have been going on for the last 20 plus years. The Mind-Life Institute. So there's some good videos produced by them that are on YouTube. I quote from one of them here. But in one of those videos, Michael Bitbol is one of the people sort of presented. So he's been involved in those. And then, there's another physicist named Vic, I'll just hold up his book, Vic Manfield. I don't know if you can see Vic Manfield. He's a physicist and a professor at Colgate University in the US. So he wrote this book, Tibetan Buddhism and Modern Physics, which is it's the most detailed comparison. And honestly, some of that, quite a lot of that is quite beyond me, especially his presentation of how the Bell's theorem inequity is, what is it? It's, what's the word for it? I could say, I don't even remember the term. It's, anyway, it's kind of broken. I forget, there's another term I'm looking for, but anyway, it gets quite technical. So some of it I don't really get. But he says a lot of good things too. I give some quotes by him. And then the most easy to understand is Universe in a Single Atom by His Holiness. Although, that's good. And I quote from that here, but it doesn't go into much detail. So Michael Bitbol, though, I was saying, he says there's one other book too, which I didn't read, that there's only 3 main books really that do much comparison. So, but I'm drawing on mainly 2. I'll jump to I made a PowerPoint slide, do it together last night, yesterday. So this, I don't have a clear outline for this one. It's more just going through, I'm going to present 2 main, we'll look at 2 main experiments in quantum mechanics. What's considered the most important one is the double slit experiment, which I found a really good website that clearly explains that with some diagrams. So we'll go through that experiment in detail. And then there's another, it's not so much an experiment, but a phenomenon of quantum entanglement. Although there is an experiment, and that's related to what I was saying. there's this EPR. The EPR is this challenge posed to quantum mechanics by Einstein, Podolsky, and I think Rosenstein. And that was a big question about. Yeah, I'll go into it later. But and then in reaction to that, there was this Bell's theorem. The Bell's theorem, inequity is denied or something like that. So anyway, we'll look at that. There's this quantum entanglement. But first, just some introductory remarks. So this is from His Holiness Dalai Lama. So, and so kind of like think about the worldview of science before quantum mechanics was discovered. Right? So quantum mechanics was really kind of discovered in the early 20th century. So before that, the predominant view of quantum science was Newtonian physics, and that continues to be. I mean, the view of Newtonian physics, from Isaac Newton, continues to be the predominant kind of worldview in physics to this day. The ideas of quantum mechanics haven't really gotten into the mainstream much, although many people talk about quantum mechanics. And I mean, one point Mikhail Bitbol makes, especially in this, I think there's this book by Kaprov, Kaprov, I forget his name, by Kaprov, Fritz Kaprov, I think, Fritz Kaprov, like the Dancing Wu Masters or something. It was popular in the 1980s, but it's very shallow and kind of invalid comparisons. So that one, yeah, is not worth paying attention to. But before, yeah, well, before quantum mechanics, the primary predominant worldview continues to be the predominant worldview of physical phenomena is Newtonian physics. So about that, both science and Buddhism describe, and so it's similar in Buddhism, also it's only the Prasangika school, the consequentialist middle way school, that really says nothing exists from its own side whatsoever. All the other lower schools, they always grasp at something existing from the side of the object. And especially in terms of physical phenomena, especially you see in the Great Exposition school, or the Vaibhashika and the Sutra school. Well, especially the Great Exposition school, they assert that there is a most fundamental, smallest building block of all physical things, so that there is a partless particle, right? That if you searched at a small enough level, you can find a kind of fundamental particle that can't be further divided into smaller parts. So that's similar to in Greek, ancient Greek, some ancient Greek philosophers, I forget who, but they asserted that the physical world is made up of the smallest possible building blocks, atoms. And so for a long time in physics, even, I mean, in some ways, even now, possibly, that was, with the atom smashers, like the Hadron Collider, I think in Europe, and then there's other ones in the US. That was kind of a quest of physics, was to find the most fundamental building blocks of physical phenomena. And it was thought that, at one point it was thought, well, the atoms are the smallest, but then it's found that atoms are actually made up of protons, neutrons, and electrons. So then it was thought, well, maybe they're the smallest. But then it was found with these powerful particle colliders that you can also smash up protons and neutrons. Electrons, I don't think you could smash up, but protons and neutrons, you could smash those up into more smaller particles like gluons and botons and the Higgs boson particle and all these smaller particles. But as it seems like as the ability to break up particles gets more powerful, you just find smaller and smaller particles. So yeah, that's what's talking about here. Looking at this quest to look for, small fundamental building blocks. So both science and Buddhism describe a divergence between things as they appear to us and things as they actually exist. So yeah, that's kind of the most general similarity here, is that in both science and Buddhism, there's a recognition that the way things appear to us is often not the way that they actually exist. Things appear to us in one way, but when we analyze to see, we find they exist in a different way. So His Holiness then says, I have the conviction that the great discoveries in physics give rise to the insight that reality is not as it appears to us. So we can just think about, what the simplest way to think about that is look how physical phenomena appear to exist. They appear to exist as being solid, right? I mean, in a way, they are solids, right? Like the table, the floor, the walls. If the walls of the house weren't solid, they wouldn't be able to hold up the roof. But when we analyze, in an electron microscope at the atomic level, actually they're 99% space. These things that look very solid, actually they're mostly made up of empty space. But that doesn't appear to our sense consciousness, only when we analyze, with powerful instruments, and also use kind of reasoning to extrapolate. Then we know that those phenomena actually are made up of many atoms. Each of those atoms is composed of a nucleus, which contains protons and neutrons, and then the nucleus is orbited by electrons, which is also kind of a misnomer. Actually, electrons don't have a clearly definable location in space or momentum until they're measured. So there's kind of an electron field that surrounds atoms. But between the proton and then the space around it, which is sort of filled with the electrons, it's mostly space. I mean, in terms of the space that any atom occupies in space is mostly empty, right? So thereby, everything that's composed of atoms is mostly composed of empty space, which is not the way things appear to our senses, right? So that's already one kind of contradiction between the way things appear to us and the way things actually exist. So then, in both science and Buddhism, earlier scholars have asserted fundamental, irreducible building blocks of matter. Since Holiness says one of the principal motives underlying scientific and philosophical inquiry, so it means in Buddhism, into the basic constituents of matter is to find matter's irreducible building block. Right? So irreducible, meaning building blocks of matter that cannot be further divided. Yeah. So in Buddhism, this is refuted by the Sutra school and the higher schools, Sutra school, and then so the Sutra school looks at what are asserted as the partless particles by the Great Exposition School, and then says that's impossible because if there were a partless particle, and you're saying those particles are the building blocks of all other things. Well, to be building blocks of other things, there has to be many particles grouped together, right? If there's many particles grouped together and grouped together, they make something larger, then they have to touch, right? So there has to be a point where two particles touch. If two particles touch, then there has to be, a side at which they touch, and then other sides that don't touch. And if a particle has these two sides, one that touches and one that doesn't touch, then that means it has to have parts, right? It's quite basic, powerful logic. So it's true. So that's why they assert there is no partless particle, because that would mean, if there's two particles and they relate, then all of their parts touch, which would mean essentially they have to be the same particle. They can't be two different particles of all surfaces touching each other. So, but then the mind-only school, their approach is completely different. They say, actually, there are no physical entities, such as a projection of the mind. Everything exists like a dream. So we just have the appearance, the illusion of particles, but actually there are no, external physical particles, because everything is just an appearance to the mind, and nothing more solid than that. But then we go back to the consequentialist school, which we hold as being, the highest and most accurate. And they say, no, there are external physical phenomena, but when you search for the phenomena, you can't find, something existing independently from various parts and then imputation upon that collection of parts. So from the side of the object, nothing exists. Everything is imputed by the mind. That doesn't mean it's a projection of the mind. There are external physical things. Things are not just an illusory appearance, but but they exist independence upon mental imputation. So that's the most difficult one to kind of grasp. That's what we're trying to do in this module. Yeah, but in short, though, it's similar. Another similarity between Buddhism and science in general, especially physics, is the tendency to grasp at fundamental building blocks of phenomena, which have inherent existence, which exist from their own side, completely independent of an observer, right? They just are building blocks out there, and things are made of that. And then as separate, discrete observers, we can just come along and find those things and recognize, okay, this is how the world is kind of composed of stuff. And then, so then obviously the next similarity is going to be that that is undermined. That whole thing is undermined. So, but so before we get to that, so that's the view of classical Newtonian physics. And this is a diagram I took from Vig Mansfield, but I found very helpful the way he sets this out. So in classical physics, or the Newtonian view of the world, you can say, then it's considered that the discrete independent reality of objects is primary, and their relationships to other objects is secondary. So you see in this diagram, the three cylinders here are kind of dark, heavy, solid. So that represents how objects are considered, to have inherent existence, to have independent existence. So the objects that because that's the view of our sense consciousness, that the objects we see around us have kind of discrete, independent, they're separate from each other, from their own side, from the side of the object. And they are what they are just in and of themselves, right? So objects have this kind of discrete, independent reality. And then the relationships between objects is something secondary, right? So primarily they're objects that exist, and then they happen to relate to each other, different times and in different ways, right? So the objects are primary and their relationships are secondary. That's the main point. So now the alternate view of quantum mechanics, right? In both quantum mechanics and Buddhism, they assert that all physical phenomena are fundamentally dependent arisings, right? So the opposite is the case, that the objects themselves are secondary. What's primary about how objects exist is the relationships between them, right? So later scholars in both science and Buddhism reject any notion of independent objective reality. And that's His Holiness speaking. And then, if on the quantum level, matter is revealed to be less solid and definable than it appears, then it seems to me that science is coming closer to the Buddhist contemplative insights of emptiness and interdependence. So here, one of the major differences obvious major differences between science and Buddhism is that Buddhists are not doing physical experiments, right? They don't have labs, and they don't develop instruments to look at the phenomena, and they don't even go out in the forest and like biologists do and kind of measure out a square in a forest and then count how many different kind of creatures are in that square and then multiply that how many are in the forest and so forth. So Buddhists just don't do that because they're not that interested in external world, right? They're more interested in what's going on with their mind. But they come to, that's what's kind of shocking, is that they come to similar conclusions about the ultimate nature of the world by just looking at their own experience and using logic and reason and contemplating, looking carefully at one's own experience, and coming to conclusions about how things exist. So, but then these physicists doing the opposite, not looking at their own minds. They're not particularly interested in emotions and psychology and stuff. They're interested in external physical world, how things, exist. So this radically different method, and then developing more and more, doing different physical experiments, developing more and more powerful tools to look at and measure the external world. But then gradually they come to almost the same conclusion that, there is no objective reality. So in that way, it's very shocking, that they come to the two completely different methods, but come to a very similar conclusion. Yeah. So that's what His Holiness says, that, science is coming closer to Buddhist contemplative insights. So Buddhist insights are contemplative insights. They come to, by means of contemplation on their inner world mostly, whereas science is, external, looking at the external kind of experimentation. So now the quantum. So this is again from Vic Manfield's book. And this is one of the most common kind of assertions that the quantum physicists make is that quantum physics, quantum mechanics is primarily saying that what's primary about the existence of objects is their relationship to other objects, without looking at, in the quantum world, without looking at quantum particles, without looking at how they relate to other phenomena than themselves. You can't posit like how they exist at all. So yeah, he says quantum particles exist in a well-defined way because, I missed a Y there. They have relationships to other particles, right? Because they have relationships to other particles, then they exist in a well-defined way. They have no independent existence, right? So that's, Vic Manfield speaking. So then more to that. So this is here. These are some quotes from this guy, Mikhail Bitbol. It's not quotes from him, actually. These are quotes from one from Elizabeth Napper and another from a quantum physicist, Heisenberg, that he presents in this. So this is from a YouTube video, actually, from the Mind Life of Europe branch of the Mind Life Institute. And they have this video on YouTube, which is called, How Can We Compare Quantum Mechanics to Buddhism? Actually, there's three or four different parts to that. This is from the first part. So my kind of summary is that both science and Buddhism are stating that phenomena are primarily relationships, that nothing, neither things nor properties of things nor views of reality are absolute, but only relative. So from the Buddhist point of view, Elizabeth Napper, in summarizing Tsongkhapa, says, well, statements which appear to reject all thesis are to be understood as intending to reject inherent existence. Yeah, Michael Bitbol kind of has this a little bit wrong view of Nagarjuna, saying that Nagarjuna says you can't assert any thesis about phenomena, that you have to reject all views of phenomena. And then Tsongkhapa's interpretation of that is that whenever it's said that there are no views, it means any view that grasps at inherent existence is wrong. He kind of goes to a wrong extreme, but in short, though, Nagarjuna and other Chandakirti, Tsongkhapa, they reject any views that grasp at things as existing as independent, discrete entities from their own side. And then Heisenberg is one of the primary founders. Well, he's not a founder, but a later quantum physicist. So in 1955, he says, quantum theory is no longer an image of nature, but an image of our relationship with nature. So in quantum mechanics, it's not held that, basically it's not held that phenomena, basically quantum particles, it's almost as if they don't exist as particles or as waves until they're measured. Right? So in quantum mechanics, measurement is found to be part of what determines how an object exists. And so much so that it's almost like an object doesn't exist independent from the act of being observed by an observer, independent from measurement. So I'm trying to expand you guys so I can see a little bit. So then the best way to show that is through the double slit experiment. So one of the most famous quantum physicists, Richard Feynman, says, if you understand the double experiment, then you understand kind of the quantum mechanics. It's the main thing to be understood. So so I found a really good website that has a nice kind of brief explanation of it, and I basically copy pasted from that. So with diagrams. So here, let's go through this double slit experiment. So first, just let's understand. So there's an experimental setup. So you have, here's my pointer. I'm starting to point with this on the screen with my finger, but you're not going to see that. So you have a photon gun on one side here. So imagine you have a little thing. So light is made of photons, right? So you can have, but these days most use a laser. But you need a photon gun where you can either just shine light from the gun, in which it's like a barrage of photons, like thousands and thousands of photons per second or microsecond. But you can also slow the, so when something is emitting light, it's emitting photons. But you can also you need a gun that you can slow it down so you can emit one photon at a time. Right. And then you have the screen in between here, which has two slits in it, and then you can block one slit off as you like. And then here you have, usually it's a photographic plate. So something that it can, when it's struck by even one photon, you can see that, you can take a measurement of where the photon strikes. So it's on here, it's called a sensor screen, usually some kind of photographic plate. So the idea is you shoot photons from a source, they go through either one or two slits, and then they strike this photographic plate, which makes a measurement of where the photon strikes. So when you block one of the slits and you fire the photons through the slit one at a time, they strike just like particles. So as if you were shooting a ball through the slit. And so what you get is just this random kind of somewhere behind the slit, shoot one photon at a time, and behind the slit, you just get this random kind of pattern of these, as if these particles, discrete particles, are going through the slit and hitting there, right? So then, yeah, so let's see if I described it right. Read what it says here. So this is from the website down here. If you block off one of the slits, so it's just a single slit experiment, and fire photons through the sensor screen, or through to the sensor screen, the photons will appear as pinprick points on the sensor screen, mimicking the particle patterns produced by sand in the previous example. So I didn't include that. From this evidence, we could suggest that photons are particles, right? So when you shoot one at a time, it appears like photons are just particles going through the slit and hitting the screen. Now this is where, so I'll keep reading. Now this is where things start to get weird. If you unblock the slit, the block slit, so you have two slits now, and fire photons through both slits, you start to see something very similar to the interference pattern produced by waves in the light example. The photons appear to have gone through the pair of slits, acting like waves. So just for a minute, imagine like this was not a photon gun, but there were waves going, like in the water. You can see this actually in the water if you look at breakwalls at a marina, and there's two blocks in a breakwall. So imagine this was like a water wave, and there was just a water wave going through here. If there's one water wave here and it goes through both slits, what happens is there's a wave coming through here and a wave coming through here. And so as those two waves progress, they interfere with each other. And when they, come to like a break wall or something, they produce an interference pattern where the crests of the waves meet. The height is double. And where the crest and the trough of the wave meet, they cancel each other out in between. So you get this kind of interference pattern. So if you just emit light, like lots of photons at one time, light from back here, then what you get is a interference pattern. So if you look up, double slit experiment online, you can find a good illustrations of this. I didn't have time to stick one in here, but so in short, though, if you emit light from here, visible light, then it comes through as two waves, and those produce an interference pattern. But the crazy thing is, right, if you shoot just one photon at a time, so remember like we were doing here, just shooting one photon at a time, and you get a pattern as if they're coming through as particles. If you open up both slits and you shoot one photon at a time, what you would expect is that, the photons are particles, if they are particles. So they either go through one slit or the other slit, right? Because a particle can't go through both slits, right? It can only go through one or the other when it goes through. So you would expect that then you would get just one lump, you know, of the place where the photons that went through this slit, you would think, you know, they just either hit around this area, like just in this one, right? If they go through this slit, you just get a kind of area behind the slit where they strike, right? So you would expect that to be the same here, that you get one area where photons strike here and one area where they strike here because they're going through those particles. But what you find, in fact, what it's saying here is that even you fire one photon at a time, you get this interference pattern, which means that it's acting like a wave when it goes through the slits, that even one photon at a time as it goes through the slit, it's acting like a wave. And then, but then when it strikes the particle plate, it only makes one mark on the plate. You know, each photon only makes one mark on the plate. And yet, you keep firing them, you get this interference pattern. So it looks like the photons are, you know, hitting the plate in the pattern as if they're a wave until they hit the plate, right? So it's a really kind of strange thing, right? So this is why it says, now this is where things start to get weird. If you unblock the slit and fire photons through both slits, you start to see something very similar to the interference pattern produced by waves, right? So how do you have a particle here, but then it seems to be a wave as it passes through the plate. I mean, as it passes through the slits, but then it collapses to it makes just one mark on the plate. It seems to be a particle, but over time, so it's almost like over time, how can a wave pattern exist? You know, how can it be a wave when it passes through the slits? And then how can it be a wave existing like over time? It's also strange. So the photons appear to have gone through the pair of slits acting like waves. So then there's more discussion, because then we're going to slightly change the experimental setup. What if you launch photons one by one, leaving enough time between them that they do not have a chance of interfering with each other? Will they behave like particles or waves? At first, the photons appear on the sensor screen in a random, scattered manner. But as you fire more and more of them, an interference pattern begins to emerge. Each photon by itself appears to be contributing to the overall wave-like behavior that manifests as an interference pattern on the screen, even though they were launched one at a time so that no interference between them was possible, right? So there seems to be no interference, no relationship to the photons to each other, and yet it's like they participate to create a wave pattern, right? It's really bizarre. It's almost as though each photon is aware that there are two slits open, two slits available. But how, right? So how can photons kind of be aware that there's either, so again, think, when the photon if it's a particle, it can either go through one, open slit or the other. And photons are just physical phenomena. They can't be aware of something, right? So you would think, again, that they would each act as if they're just going through one slit. But it's when both slits are open, they act differently, it seems. So how can a photon going through one slit be aware of the other? So the only way is to think, well, it's a wave as it goes through. So it's almost as though each photon is aware that there are two slits available. How? Does it split into two and then rejoin after the slit, after it goes through the slits and then hit the sensor? So to investigate this, scientists set up a detector that can tell which slit the photon passes through. All right, so the same experiment, but set up a detector here, which is measuring, these photons as they go through the slits to see, are they going through just one slit or the other one, and which one, right? So again, we fire protons. So we set up the detector, and then again, fire protons one at a time at the slits, as we did in the previous example. And the detector finds that 50% of the photons have passed through the top slit and 50% through the bottom slit, and confirms that each photon goes through one slit or the other. So there's nothing too unusual. So we set up a detector, and as we fire one photon at a time, we can find the photons either go through, 50% go through the top slit and 50% through the bottom slit. But then that changes the result here. Then what you get is not an interference pattern like here, right? Rather you get these, it's like these two discrete areas where the photons hit, because it's as if they act as just particles going through one slit to the other. So when you put this detector here at the slits, they no longer act like a wave going through the slits. So how can that detector there, change the behavior of the photons going through the slits? That's the kind of the real mystery. And one of the real mysteries. There's many mysteries this experiment elicits. This pattern matches the one we saw when we fired particles slits. Yeah, it appears that monitoring the photons, so the act of measuring the photons here at the slits, triggers them to switch from the interference pattern produced by waves to that produced by particles. Right. So if the detection of photons through the slits is apparently affecting, so if the detection, of photons going through the slits is apparently affecting the pattern on the sensor screen, what happens if we leave the detector in place? So leave the detector here, but switch it off, just turn it off. So you don't tell the photons that we're spying on them. This is where things get really, really weird. So you leave the detector there, but you just turn it off. The same slits, the same photons, the same detector, just turned off. And we will see that the same particle-like, we will see this. So will we see the same particle-like pattern? No. The particle again makes a wave-like interference on the sensor screen. So if you just turn the detector off, then it seems like when you fire the photons, they act again like waves going through here. So this is where you get this thing in quantum mechanics called the collapse of the wave function. So what it means is that when quantum particles, before they're measured, they exist as a wave. And that wave is described by a kind of probability equation called the Hilbert. Well, it's in Hilbert space. It's what is it? So I think it's Schrodinger's equation is used to describe, the wave function of a quantum particle. So what it means is that before the, so where's my cursor? Come back, cursor. Before the, so here when the detector is off, before the so a photon is a quantum particle. So before the particle is measured, it exists as a wave, and that's why when it goes through the slits, it's not really known. You can't say it goes through either slit. In essence, it's a wave going through both slits. So it's like here at this point, it's a wave, but then when it's measured at the plate, it collapses from a wave into a discrete point, a particle. So then when you turn the detector on and it's measured here, then at this point, the wave, which is like a wave, once it's emitted from the gun, in the space between, it becomes a wave because it's not being measured. But then when it's measured, like in this diagram, when it's measured at this point, it collapses into a particle and goes as a discrete particle through one slit or the other. So there's this thing called collapse of the wave function. So this one of the most essential assertions in quantum mechanics is that it's the act of measurement on a quantum particle that makes it collapse from being a wave, which is described by is a probability. You can only, when a quantum phenomena is in the state of a wave, you can only describe with a probabilistic, prediction where that particle will be found. It doesn't have, so in essence, it doesn't have a precise location. It doesn't have a precise momentum. It only possesses this set of probabilities what its momentum will be, or where its location will be found to exist at the time it's measured. So the assertion is that in essence, it doesn't have a precise location until it's measured. So the act of measurement is deterministic into how it exists. So that's how you get to the object doesn't have an independent existence, right? So this shows that, like, how can the act, I mean, this is one of the big mysteries. How can the act of measuring something affect, whether it's a wave or a particle, right? So Vic Mansfield then stresses, and he's quoting Bohr. So Niels Bohr is one of the founders of quantum mechanics. So says Bohr stresses the impossibility of treating quantum properties independent of the entire measurement situation. So think, whether the detector is on or off in the double slit experiment. That defines what phenomena can occur. So think, if the detector is on, then they act like a particle. Photons act like a particle going through the slits. If it's off, then they act like waves going through the slits and produce an interference pattern. So Bohr stresses the impossibility of treating quantum properties independent of the entire measurement situation that defines what phenomena can occur. From a Buddhist perspective, we would say, so Mansfield is a Buddhist. I mean, yeah, he talks about, studying at the Namgyal's Institute in, I think, I don't know, Ithaca, New York. So then he has a good understanding of Buddhism, Mansfield. So from a Buddhist perspective, we would say that he is explicitly denying inherent or independent existence to quantum properties, right? So Bohr is saying the impossibility that it's impossible to treat quantum properties independent of the entire measurement. So apart from the act of measurement and the circumstances you set up to measure something, that determines how things, appear to exist, and actually do exist. You can't, treat quantum properties independent of the entire measurement situation that defines what phenomena occur. So things don't exist from their own side; they exist only, independence upon the act of observation. So from a Buddhist perspective, we would say that he is explicitly denying inherent or independent existence to quantum properties. He is stressing how quantum properties can only be defined within the context of the entire experimental setup. The very properties we can consider are dependent upon the precise configuration of the experimental setup. Yeah, and then just some more by him. So he says, for example, when the theory says that, so when quantum theory says that the probability of the photon being measured at a certain time and place is 1/3, it is not, so this is a little add-on. So, okay, so I'll just read it first and then explain it. It is not referring to an objective matter of fact, but only what to expect. Yeah, it's only referring to what to expect in a future measurement. There is no objective state with well-defined properties prior to a measurement. So just think about that. There is no objective state with well-defined properties prior to a measurement. Right? Before a measurement, nature is objectively indeterminate in a state of pure potentiality. So just to illustrate that, what he's saying is, like, in terms of the double slit experiment, like when you fire a photon from the photon gun, at that time it's a discrete particle, right? But then at the time it's measured on the plate, it only hits one place on the plate, right? So at that time it's a discrete particle. But in between being measured, in between, it's kind of a known entity here and a known location here. How does it exist in between? Right. So quantum mechanics shows it exists as a wave in between. But here, I mean, Mansfield is adding that, because, and this is something new I learned preparing for this. I thought, well, that the wave in this place, the wave is kind of a well-defined thing. But what Mansfield is saying is that in between here, the wave it exists as a probability wave. So there's the only thing that's known about the phenomena, in between, is that, sure, okay, mouse. The only thing that's known about the wave in between is a probability of where the particle will be found when it's measured. And so, so Mansfield is like saying the only description you have is a probabilistic description of, there's no, that equation in quantum mechanics is used to describe the superposition. It's called a superposition of the particle. The particle's in a wave. When it's in a wave state, it's in a superposition, which means it's it's not in any discrete definable position. It's in a state in which there's only thing that's known about it is a probability of where it might be found when it's measured. And Mansfield, I mean, the thing that really blew my mind is he said the space, in which that wave is considered to exist is called a Hilbert space. And that space has infinite has infinite dimensions. It's not even just a two-dimensional, like the screen of your a page, like the surface of a page or the screen of a computer is two-dimensional, or three-dimensional, like has depth, or four-dimensional. It's the Hilbert space in which the probability wave of particles is defined to exist. It has infinite dimensions. So he says it's not like that wave exists in space in the way we, in a way that we can conceive of things existing, because the ordinary way we conceive of things existing in space is in terms of like Newtonian physics, classic physics. So he's saying, try to think of infinite dimensions. What does that even mean, right? So he says that's the kind of way that the particles exist when they're in a wave state before they've been measured, right? So let's just look at what he's saying again. All right, now I want to get rid of this bar. For example, when a theory says that the probability of the photon being measured at a certain time and place is 1/3. So imagine there's 1/3 probability that when we measure a particle, it exists in this place. It is not referring to an objective matter of fact. So it's not like the particle is in a place and we just don't know it. And when we measure it, there's 1/3 chance that it's going to be here or 1/3 chance it's going to be there. So it's not referring to an objective matter of fact, but only to what to expect in a future measurement. So it's only saying when you make the future measurement, this is what you should expect. There is no objective state with a well-defined properties prior to measurement. So independent of actually observing the phenomena, it doesn't exist. That's so similar to the crossing-eco view of it, right? Before a measurement, nature is objectively indeterminate in a state of potentiality, right? So then to add some from His Holiness in the Universal Single Atom, he says, in quantum mechanics is one, particles exist in a superposition until measured, and yet ordinary objects seem to stay in a largely fixed state. So yeah, how is it that ordinary objects like, the table, the phone, chair, our body, they seem to be in a stable, largely fixed states? So he compares this kind of duality between the superposition of particle, quantum particles, and yet larger ordinary objects having a stable, fixed states to the two truths in Buddhism. In Buddhism, we have a conventional nature or conventional truth with distinct identities and the function of causation. And yet they have an ultimate nature, ultimate truth, such that they do not possess discrete independent realities. So the ultimate nature, ordinarily things appear to exist from their own side and they act kind of as discrete independent objects interacting with each other. But when we analyze, can't find the objects, right? They seem to not exist from their own side whatsoever under analysis. Okay, so that's that. I've already gone past my time, but again, we'll just kind of breeze through the last bit. So the second one thing I want to look at is quantum entanglement. So here, the reason this diagram is because quantum particles, basically, they have a spin. Each particle has a spin. So they either have, you can describe as simply as just an upward spin or a downward spin. So the idea here is that, so this is a different experiment where you have two, and I don't have a good diagram of this, but you have two. So again, like from a photon gun or something like that, something that emits quantum particles in a controlled way. You have two particles that are entangled, and they have a close relationship with each other. And then you emit them from one source, and then you split them off with like a powerful magnet. You can split them so they go off in different directions, right? So, and you can send them in different directions so they can go at infinite distance. And then you measure, their spin. Are they spinning up? Or are they spinning down? So if two quantum particles are entangled, then their spin should always correlate, such that if one is spinning up, the other has to be spinning down. If one is spinning down, the other has to be spinning up, right? So they always have that kind of correlation. So, but the thing is, until you measure their spin, you don't know if there's, which way they're spinning, if they're spinning up or spinning down. And actually, they're not in a definable state, as we just looked at. But so then you add the fact that, okay, so imagine you emit these two particles, two entangled particles from one source. And then before they're measured, they're not in a definable state of being spinning up or spinning down. But then as soon as you measure, they become, the wave function collapses and they become in a fixed state where either they're spinning up or spinning down. So if A is found, make a measurement on particle A and it's found to be spinning up, it only becomes that it's spinning up at the time you make the measurement, right? Before that, it's not in that state. So, but then at the time you make the measurement, instantaneously, particle B, which could be very far away in a different direction, it has to exist in a correlating state with particle A. So if particle A is found to be spinning up, it only becomes spinning up at that moment. And at that very same moment, particle B has to collapse from a wave function into a discrete state of spinning down, right? But the problem is, which is the EPR question, Einstein, Podolsky, Rosenstein, EPR paradox, is that information can only travel from one place to another at the speed of light. Nothing travels faster. Nothing travels faster than the speed of light, right? So how can, if an entity is found, it only becomes one state at one moment. It cannot instantaneously convey information to another place, faster than the speed of light, in short, right? So Einstein and company are saying that, well, actually those particles were in a fixed state when they're emitted from when they're emitted from a source, they're already in that state, and you're just discovering what it is later on, right? There's this famous quote by Einstein: "There's no spooky distance, no spooky action at a distance." So he's saying it can't be the fact that it can't be the case that really it's in an undefined state before you measure it, but then instantaneously there's this action at a distance. Instantaneously, one particle's being in one state affects a very distant particles being in a different state. That can't be the case. But then this guy Bell, I forget his first name, in the 1960s, I think, this guy Bell came up with a way to test whether the particles are in a defined state, before they're measured or not. This is the part where I get lost, because I really don't understand how he came up. It's called Bell's theorem. I don't understand his theorem. I don't understand how it's disproved, but I understand the conclusion. This is what I'm going to tell you, is that it's found that, actually it is the case where and these two particles can be, infinite distances apart, these two entangled particles. But when and I'll give a quotation from like a NASA website to make sure I'm not making any mistakes. But when you measure one particle, it's found to be in one state, and instantaneously other particle collapses into an opposite and correlating state. So, and Mansfield points out that it's not that information moves from one to the other faster than the speed of light. That's not the case, because that really can't happen. Information can't move faster than the speed of light. But what is the case is that actually those two particles are in essence part of one entity. They're not, even though they're totally in separate spaces, they're still, well, I'll read what Mansfield says. It's more powerful than anything I can say. So let's look. So that's kind of roughly what's going on when I'm talking about quantum entanglement. So, okay, this is from the NASA website. It says, in quantum mechanics, all the forces of nature are mediated by exchange of particles, such as photons. So this is the building blocks of everything. And these particles must obey this cosmic speed limit, so they can only go at the speed of light. So an action here can cause no effect over there at a different place any sooner than it would take light to travel, from point A to B in a vacuum. That's the fastest anything can go. But two entangled particles can appear to influence one another instantaneously, right? Faster than the speed of light, whether they're in the same room or at opposite ends of the universe. So pretty spooky indeed. So that's referred to Einstein. Quantum entanglement occurs when two or more particles interact in a way that causes their fates to become linked. So I don't understand how particles become entangled or unentangled. That I don't know. It becomes impossible to consider or mathematically describe each particle's condition independently of the others, right? So two entangled particles, they can't be described independently of each other. They're intimately connected, even though they might be infinitely far apart. Collectively, they constitute a single quantum state. Oops. Okay, so that doesn't really explain the thing, but it just says some things about it. Yeah, that doesn't explain the experiment. Yeah, it's quite a complicated experiment. We're already out of time anyway, so am I talking? So, but here's some Mansfield's conclusions after he describes that experiment. In summary, non-locality, right? So this is called, yeah, I mean, one aspect of this is one aspect of quantum particles is that they have non-local characteristics, which means, in Newtonian physics, if there's a particle, it exists independently in one place and at one time. And you can know everything about the particle just by reference to that, that particle in that place and that time. In quantum mechanics, if two particles are entangled, you can't know everything about that particle by just looking at that place, because it can be directly affected by something at a far different place. Therefore, it's non-local, right? It's not completely local. So there's this aspect of non-locality. I mean, another aspect of non-locality is that it's not clearly definable. Well, the more you know about a particle's position in space, the less you know about its momentum, right? About how fast it's moving. The more and the direction of its movement. The more you know about its movement, the less you know about where it is in space. So you can't know both. That's another aspect of non-locality. But in summary, it says non-locality is asking us to revise completely our ideas about objects, to remove a pervasive projection we have upon nature. We can no longer consider objects as independently existing entities localized in well-defined regions of space-time. Non-locality teaches us that the properties at one location instantaneously depend on the properties found at arbitrarily large distances, right? And then it is worth repeating that the interconnections spoken about here are not like those in classical physics, those limited by the speed of light. These are instantaneous interconnections. These quantum correlations reveal that nature is unified in ways we only dimly understand. Right. Okay. Oh, great. And that's the end of yeah. So yeah, especially I know that quantum entanglement, the second part, it's difficult for me to clearly explain. But if you're curious, you can find a lot of good explanations, like on the internet or yeah, different books. So yeah, I'm hesitant to ask if you have any questions because probably can't answer whatever questions you have about this. But yeah, I don't know if you have anything that maybe some interesting thing to add, or interesting question that came up. It's always good just to consider questions even though we can't answer. So and then yeah, so we can discuss a little bit for a minute, and then we'll have a break. Everything else we usually do. Any questions or comments come up for you all?
Hi. So you were saying that our mind in things don't exist until our mind imputes them?
In Buddhism or quantum physics?
Buddhism.
In Buddhism, yes. Yeah.
And how can then why is the mind-only school incorrect? I thought that's what the mind-only school said, that things only exist according to the mind.
Well, I mean, yeah, okay, so the mindless school does say things only exist according to the mind, but in a completely different way. Right? So the mind-only school is saying everything is like a dream. Like, think about when we dream, everything that appears in a dream is purely a projection of our mind. It's just things, an appearance created by our mind. So yeah, in that way, I mean, it sounds similar, things created by our mind, but in the mind-only school, it's things created by our mind as if there is no external world, really, that everything that exists is just an appearance to our mind that's created by imprints in our own mind. Whereas in the consequentialist school, the one that we accept, right, they're saying that there is an external world. There are external physical phenomena which are not just appearances cast by the mind. But the way those things exist is independence upon imputation by the mind, right? So there's a collection of parts, I mean, which is also, so things that exist independence upon the mind, but they're not mere appearances cast by the mind. They're not mere appearances to the mind, right?
I guess I'm still a little bit hung up on things don't exist unless you impute them, and also saying that the external world exists. Like, how do you reconcile that?
I know it's difficult. And actually, when we in the monastery, before we study the middle way, we studied the mind-only school view for a full year. You just study the view, actually for 2 years, but mainly for 1 year, because it's considered like to really understand the consequentialist middle way view, you have to understand the middle way view first, and then understand like how they're different. So the difference between those two is one of the most difficult things in Buddhist philosophy, because it's very subtle, right? The middle way school view is already very subtle, but then the consequentialist, the mind-only school view is very subtle, and then the middle way school is a critique of that. But yeah, and I also find in my personal experience, yeah, it's one of the most difficult things to think, well, how do imputing an object, how does that bring it into existence? Because it's totally counterintuitive, right? Is that your question, right? How does imputing an object bring it into existence?
Yes, because I mean, I thought that you were working from the premise that the outside world exists and that things function. So if things are functioning and there's an outside world, then why is it only considered valid when you impute it? And our imputations are wrong anyway, according to what
not only considered valid, but it exists. Well, yeah, that's one of the big mysteries. But that's one place where looking at quantum mechanics really helps. But before looking at that, the double slit experiment, it really kind of illustrates that. But I mean, also, I mean, one of the things that makes it more difficult to understand that too is because we have this common view of things based on Darwinian evolution. Okay. We think that it looks like the Big Bang. At the Big Bang, there's no mind. There's nobody. There's no people for sure. And then from the Big Bang all the way up till for billions and billions and billions of years until the first life on Earth. Well, first life, even then there's just plants, right? There's no mind then. And then only until there's living, sentient organisms, animals. First there's animals, okay, then there's mind. So we have this idea that there's no consciousness existing before the first animals on Earth. And definitely nobody thinks of like teacups until there's humans. So, so then how, but then the Big Bang exists, obviously, in these planets and things, solar system, other, what do you say? Anyway, all kinds of things exist before there's consciousness, it looks like. But in the Buddhist view, yeah, things don't exist without being imputed by the mind. So how does that work? Well, there's different ways to look at it. One, the Buddhists posit many more sentient beings than we commonly think of, right? There's humans, there's been, well, there's been humans in universes before our universe, back for countless time. There's no beginning to time. Then there's also there's beings of the form realm and formless realms. So there's all kinds of beings that aren't humans and aren't animals, that and have clairvoyance and can see things at great distances and perceive things in ways we can't even imagine. And then there's also enlightened beings, right, who know, have omniscient mind, who know all phenomena. Although the problem with enlightened beings is they don't have concepts, right? They perceive, they know everything non-conceptually. So there's a big question: can you use a Buddha's mind as a basis for saying that they impute something on an object? Can, if there's only Buddhas, there's another question. But if there's only enlightened beings, then there's no conceptual consciousness. So how can anything exist if it's imputed by concepts, right? And they don't have concepts. So these are some really difficult questions, which, yeah, I don't have easy answers for. But generally, when when we debate on the debate courtyard, we just say, yeah, at the time, you don't have to say, when the Big Bang exists, for example, then well, okay. To help answer your question, maybe this is the best way to think about it is, well, when did the Big Bang come into existence? Like we look now at radiate that, like background radiation and other data that we receive. We see these waves in the universe and look at the movement of, what is it, galaxies. So that's the word for galaxies, the movement of galaxies and the redshift, and then we extrapolate that, oh, they must have come from this finite point in the great distant past, like, I don't know, 14, 15 billion years ago. But yeah, it's a little difficult. It's like but the concept of Big Bang, that only came into existence recently. That concept of that idea. So, so it's like looking at a whole bunch of data, we've come up with a concept of the Big Bang. So in a sense, like what we're talking about, the Big Bang, that did, if no one ever conceived of that, there could have been all the same, we're imputing Big Bang on a whole set of data, right, as a base of imputation. So we could well imagine, before, like say 500 years ago, before anybody had the concept of Big Bang, all the basis of imputation, all those phenomena, basically, backward radiation and the redshift, and the movement of different galaxies away from each other at certain velocities and having certain mass, that, all that exists. But does Big Bang exist at that time? What does it mean for Big Bang to have existed at that time if it doesn't exist in the awareness of anybody? Even if it is something true, it's like, yeah, we can easily, we jump to the conclusion that, oh, well, it just existed and nobody knew of it. But in, like, how does it exist at that time? It's like it definitely doesn't exist in the same way as it does now, where we have a concrete idea of it.
So, according to Prasangika, can you say that there is a basis of imputation separate from your mind, and you imputing on
Also,
it?
you have to think not just in terms of your mind, but in terms of any mind, right? Any consciousness, any awareness. So no. In short, though, the short answer is no. Also, the basis, because that's the other thing. We think about Big Bang, we think, okay, well, maybe the idea of Big Bang didn't exist before, but all those, the basis of imputation, all those phenomena which are leading us to impute, Big Bang so many years, those still exist. We do that with the same, when we do the analysis of the person. We think, okay, well, maybe I as a person don't exist, but still I have my body and mind. They exist independently. And then we have to do the same analysis with relation to our body, the same analysis in our mind, and we find those also are based on parts and imputation. So no, the deeper we go, any basis of imputation, we analyze that and we find it's also imputed on its own basis of imputation. And then we analyze that basis, That's also imputed on his spaces. And we just go deeper and deeper and deeper, and there's no bottom, right?
Is this solved
Everything
by,
is,
is this solved by dependent arising? Like, can you then say that things are dependent arisings?
yeah, that's how it's solved. Because at that point, when you keep analyzing and see nothing exists from its own side, there's a danger of falling into nihilism. Then you think, well, nothing really exists. So that's resolved by dependent arising. You look just and see, when we don't analyze, without analyzing, things function, right? Even though when we analyze the things that are function, they're unfindable under analysis. We can't find something existing from its own side that is that thing. But yet, when we don't analyze things, they do function. So that's where we have conventional reality. When we don't analyze in a conventional way, things function according to our everyday concepts and ordinary way of relating to phenomena. But when we analyze, we find, ultimate truth. From their own side, as discrete, independent entities, things don't function. I mean, things don't exist, right? From their own side at all. So, yeah, that's the real trick, is how to find the compatibility of these two. That things don't exist from their own side, and yet they do function in everyday life. I mean, and that's the same thing His Holiness is saying here. And I mean, His Holiness. So here, His Holiness saying in Buddhism, there's a conventional nature, which is distinct entities and the function of causation, right? Causes produce effect. Yet they have an ultimate nature such that they do not possess discrete, independent realities. Those things that they have no discrete, independent reality. So he's saying that's similar to, in quantum mechanics, particles exist particles exist in a superposition until measured. So what does that mean? Again, in the double slit experiment, the particles exist in this undefinable state, like here, between when they're fired and when they're measured. They exist in a wave, a superposition that only has a probabilistic description of its existence. So it doesn't, like Mansfield says, when particles are in a wave state, they don't exist in any ordinary way that we can conceive of, and yet they collapse to a definable, location, and in time, in space-time, right? So it's real strong similarity. I mean, kind of uncanny sort of similarity between the quantum, mechanics description of quantum phenomena. So how is it that quantum phenomena can behave in such a bizarre way, and yet the things, all the physical things we perceive around us, behave in such an ordinary way, right? It's very similar to the Buddhist two truths.
Thanks.
Okay, we should do breakout rooms now for 15 minutes. In the breakout room, yeah, I'd suggest you just discuss kind of, anything from science dependent arising, especially if you can discuss the stuff I was going over here, quantum mechanics, dependent arising, how they, I don't know. There's lots to discuss, I think. So let's do 15 minutes. So any questions or comments arising from your discussions? Yes, Jorge.
I have a couple questions. First question is, if we assume, well, we know that there's other life in this universe or galaxy, are we still allowed to call it human realm? Or I heard you could call it God realm, maybe?
Well, human realm doesn't refer to the whole universe or whole galaxy. It just refers to kind of the state of the whole kind of common state of people who exist as humans.
Oh, so
When we say human realm, we don't mean like planet Earth or the Milky Way or something like that. We
Okay.
just kind of mean this. It's almost like the mindset. the state of existence of people who have taken rebirth as humans. Then the animal realm is kind of the state of existence of beings who have taken rebirth as animals.
Can we assume that within samsara that the levels are like a constraint that you can't go from one realm to the other without dying? Is that the only way to go through it?
Oh, that's a good question. Yes. Yeah, you have to die and take rebirth. No? Anne says. Yeah. Anne, can you say how can you go from one? I mean, there are cases of like, like psychic ability and physically like roaming to another, but you're not really in that state. Like what were you thinking, Anne? Just speak up.
Yeah, I think where you were going, like the being in states of mind that were like a different realm, or then aren't like some holy beings can jump around, right?
Like there's examples of Moggallana and Shariputra, the two direct disciples of Shakyamuni Buddha, like like by the power of their psychic ability traveling to like the hells or some other realms and seeing beings, but they're not part of that realm. It's just like we can see animals, but that doesn't mean we're part of the animal realm, right? Like, and then when we talk about, but we can also generate like through meditation, we can generate good, if we generate good concentration, calm abiding, then we can generate mental, minds that belong to the form realm or the formless realm. But we're still a human, right? We're just generating a mind that if we were to die and take rebirth through the force of that mind, it would cause us to take rebirth in the form realm or the formless realm. So, to as a person to kind of actually be part of a different realm, you have to die and take rebirth in that realm. Okay. But other questions more related to like quantum mechanics and emptiness. Or any other aspect of science. I mean, there's a lot of other, okay. Bei?
Okay, yeah, we actually had a pretty good discussion in our group, and mainly about why whether it's helpful to study quantum mechanics, or like why are we discussing this, and is it helpful for our own practice, or how is it helpful? And I'm curious to know your view, and perhaps maybe if you have an insight, why is holiness advocate us or the monks to study quantum mechanics?
I mean, in my experience, it's very helpful because it really does help break down our fixed concepts about how things, exist. And well, that's why I started off with just showing that in both science and like in Buddhism, because think of what what the Buddha said is the root cause of all suffering, is that we accept that things exist in just the way they appear to us. Things appear a certain way to our sense consciousness, especially the certain things appear as very attractive, and we think they really are attractive from the side of the object. And then we think, to be happy, I have to have that. And we go chasing around after, endlessly chasing around after things that appear as attractive to us. And then things that appear unattractive, whether it's people or other things, we think they're bad. I can only be happy if I'm away from or separated or destroy those. And then we try to avoid those. So we spend our whole life kind of chasing after, by the force of attachment, chasing after some things, and the force of aversion, trying to avoid other things. And those things, attractiveness and unattractiveness, they don't exist from the, exclusively from the side of the object. And we exaggerate the degree of attractiveness or unattractiveness there is there. We exaggerate completely, and we exaggerate the way we exist. So there is, I mean, the Buddha was saying a fundamental problem is that we just accept things as existing in just the way they appear. So we need to break that down, to analyze, to see, how do things really exist, and how are the appearances false. Science does a similar thing. in general. And then especially, I mean, at a very deep level, then in the Buddhist, side, the Madhyamaka philosophy, breaks things down to an extreme level till it's almost like, things don't exist. They just barely exist. And in quantum mechanics, it's the, in terms of science, they do the most extreme, kind of a deconstruction of things, that really, I mean, and I find it's very compelling, like I said, because it's completely different methodology, completely different motivation, but come to extremely, similar conclusion about, the fundamental way, on the one hand, the physical things exist in terms of science, and then in terms of Buddhism and the way everything exists. So I find it, yeah, very helpful, because basically, I mean, there's the basic principle of the more kind of divergent, different lines of reasoning arrive at the same point, the more you can be sure that that point is real, is accurate, right? So we need to think about things in very, very, very different ways. And then if they really converge on one kind of conclusion, we can be quite sure that that actually is true. Yeah, Urs?
I have a different question. In Buddhism, we talk a lot about dependent arising, and it always has kind of a rigid flavor to me, a deterministic flavor. I mean, if cause conditions come together, then we must have the result. Now, in quantum theory, we talk about probabilities and randomness and measurements and so on. Is there room for randomness or probabilities in Buddhism? I mean, do they talk about, random things? Is that possible?
Yeah, that's a great question. No, it's true. And when, there's all these debates between, I mean, we're not looking at so much, but there's a lot of debates between like the Madhyamakas and then the other schools of Buddhist tenets, the mind-only school and the Sutra school, the Great Exposition school. So that's all. I mean, I know for you all, we're not going through there's these four main tenet schools in Buddhist philosophy. That's not part of discovering Buddhism. So if you continue on to take like exploring Buddhism or these other courses, you can look at that more. But in short, though, the other schools, especially the Sutra school, they always say, look, if nothing exists from its own side, how can dependent arising work? Like cause and result, they can't function, because for things the specific causes to give rise to specific results, that entails inherent existence of things, right, by nature. So yeah, the response is that no, it doesn't. In short, that no, I know in dependent, especially dependent arising by causation, it does have a flavor of, yeah, it's necessary that this set of causes gives rise to this set of results. But yeah, you always have to go back to the analysis of, when you say, okay, this cause, what do we mean by this cause? And when we analyze, like, think of like a cause of a corn plant, the corn seed, it arises from the seed of corn. It does seem, yeah, that there is some kind of inherence to, yeah, a corn seed. It only produces a corn plant and not a rose bush and not a rice, a rice plant and not something else. But then analyze the seed. What is the seed actually, the corn seed? It's also a collection of parts. It's a collection of different molecules and chemicals. So under analysis, it breaks down. There is no just something seed from its own side. And then you'd have to analyze. Look at the ability within the seed. It says if it has inherently, the potential or the power to produce a corn plant, then when we analyze, we should be able to specifically find something that is that potential, right? If that's something, that necessity that a corn seed can only give rise to a corn plant, which is true. But if it inherently exists from its own side, well, first of all, that characteristic of the corn seed, it shouldn't depend upon anything else, which is ridiculous, because of course it has to depend upon many things. we have to think, what does it mean if it exists from its own side inherently? That it means it can't have a relationship to anything else. But obviously, no cause without other conditions can produce any result. And we should be able to find that specific potential or the necessity of that corn seed, to give rise to a corn plant. And when we look, you can't find that kind of thing. All you find is different parts, the different chemical compounds that make up, and the different parts that make up the corn seed. So, but then it appears, well, those compounds, they exist just as they are from their own side. It's always the case. We do the analysis and we break down one level of things appearing as inherently existent, but then the basis of immutation, the parts, they appear to inherently exist. So then we have to do analysis and analyze those, and then. So gradually, yeah, it's one of the most uncomfortable things, though. Yeah, that's why we veer towards the extreme of nihilism. That seems like when analyzed and things don't exist from their own side, but then yet they function. Yeah, I asked one of my teachers about, I don't know, one time we had attended teachings in Bodh Gaya by His Holiness, and what was, if he learned anything new, because he's an incredible scholar. And he just said, well, not really, but just how difficult is this problem in the Madhyamaka view of saying that nothing exists from its own side, and yet in the conventional world, things function. It's difficult, so keep thinking about it and look for better and better answers, right? Okay, we should stop there, but I hope at least this kind of perked your interest. And yeah, if you're curious, it's definitely a lot of food for thought to go reading and learning more and more about quantum mechanics and physics and other aspects of science in general. In general, to help us reduce our ignorance, grasping at inherent existence, anything that's helpful to increase our understanding of dependent arising does that, right? So the more we increase our understanding of dependent arising, the more we reduce our ignorance, grasping at things existing independently. And so studying all branches of science and many branches of knowledge in general increase our awareness of dependent arising, like biology or chemistry or psychology or all kinds of history. Even history is all about dependent arising, in effect, right? So anything that we want to increase our awareness of dependent arising. So many fields of knowledge can help us do that. Okay, so let's dedicate briefly. Sorry, we didn't have time for meditation today, but definitely next week we'll do a lot of meditation. So next week's session is just a summary of everything we've gone through, and then we'll meditate quite a bit. So rejoice in whatever merit we've created. Think back to our positive motivation you set at the beginning of the session. And rejoice in one's own effort and the effort of all the others in our group. And I can rejoice in all the virtuous things, activities done by ordinary sentient beings like ourselves throughout the world, and then holy beings, Buddhas and Bodhisattvas. How wonderful. So all this merit we dedicate, in short, that all beings are free from every form of suffering, especially wars, the war in Ukraine and other places, and violence in general, and hunger, thirst, loneliness, depression, mental illness. All forms of suffering quickly come to an end. And that all beings have well-being and happiness up to full enlightenment. And then all of our own actions only contribute to the benefit of sentient beings and don't cause the slightest harm. And that the teachings of wisdom traditions, such as the Buddhism and others, continue to flourish far into the future. And that our teachers and others who lead those different wisdom traditions have long and stable lives. Okay, thank you all. And may this center, Ocean of Compassion Center, the Ogyatso, continue to prosper and flourish. Okay, have a great week and see you all next Tuesday.
Thank you, Venerable Listock,
Thank you.
Mary Ellen and Herbs, and everyone.
Thank you, everyone. Bye.
Night.